That's a pretty powerful idea, isn't it? It frames time not as some flowing river you can just navigate, but more like a finished book. And if you try to change even a single word, you risk unraveling the whole story.
All right, so today we're going to push way beyond the familiar sci-fi stuff about time travel. We're diving deeper. We're asking a much more fundamental question. What do the laws of physics themselves actually have to say about causality? We're going to explore why something as simple as sending a message to the past could challenge the very structure of our universe.
So this is it, the core question. Is causality just a suggestion? Or is it one of those hard and fast laws of physics you just can't break? I mean, really, can an effect actually happen before its cause? And if you tried, what would the universe do to stop you? That's the fundamental conflict we're digging into here.
Let's kick things off with the big one, the paradox everyone knows. It's a true act of temporal defiance. This is that classic scenario where a time traveler tries to do the one thing they absolutely shouldn't, erase their own past.
The key thing to get here is that we're moving past philosophy. From a pure physics perspective, the grandfather paradox describes a universe that is just not self-consistent. It's a system that contains its own negation, which, by definition, is a logically impossible outcome.
And this just lays it all out perfectly. Let's just trace the logic. On the one hand, the traveler has to exist to even go back in time. That's the precondition. But then, the action they take in the past, on the other hand, completely erases that very precondition. The two causal chains can't exist together. They're mutually exclusive. This isn't some infinite loop, it's a structure that can't even form in the first place. One side literally annihilates the other.
Okay, but let's just assume for a second you could somehow dodge a direct logical contradiction like that. Even if you could, the universe presents another problem. And this one is maybe even more insidious. Its profound sensitivity to any change, no matter how small.
Now, what's really wild is how this scales the problem down to an almost microscopic level. Forget stepping on a butterfly. The source material suggests that a mere 10-minute delay in a past encounter could mean a completely different sperm cell fertilizes the egg. That doesn't just change history, it creates an entirely different person. The traveler's own existence hinges on one precise, singular chain of events. Any interaction, anything at all, makes the traveler an orphan of a timeline that just doesn't exist anymore.
So if direct contradiction is forbidden, and even the tiniest changes spiral into chaos, what if we try something simpler? What happens if we try to send just a single bit of information back in time? Well, this is where we run straight into the elegant and kind of terrifying idea of the causal loop.
To really test this, we need a theoretical tool. So, enter tachyons. These are hypothetical particles, and their whole deal is that they always travel faster than light. Now, because of the wonderful weird rules of relativity, that means from certain frames of reference, they're actually traveling backward in time. So sending a message with a tachyon would be like creating a closed time-like curve, basically a pathway through space-time that loops back on itself. It is the cleanest way you could possibly test the laws of causality.
And this scenario is the perfect demonstration. At t+5 seconds, your friend slips on a banana peel. You feel bad, so a minute later, you send a tachyonic message back to 1 second before the slip, warning them. So what happens? Your friend, who was just walking along, gets the text, looks down at their phone at t=0, and is distracted just enough to slip on the banana peel. Your attempt to prevent the event became the necessary cause of the event. The loop is perfectly self-consistent.
This leads us to the big resolution here. The universe, it seems, doesn't need to invent brand new rules just to deal with time travelers. The rules we already have, it seems, are more than enough to make sure reality never contradicts itself.
And that resolution has a name, the Novikov self-consistency principle. Essentially, it says that the laws of physics will always conspire to prevent a paradox. If you travel into the past to change it, you just can't. Why? Because you are always a part of that past. Your actions are already woven into the fabric of the history that led to you going back in the first place. The probability of you creating a paradox isn't just low, it is, and always was, exactly zero. And so that's where we end up. If Novikov's principle holds, a time traveler has zero free will in the past. They're just an actor in a play that's already been written, fated to play their part perfectly to make sure the story remains exactly as it always was. They can observe, they can participate, but they can never change a single word. So what does that say about the nature of free will in a universe with causal laws that are so unyielding?